Dear students, in today's video we are going to learn about some of the properties of light. We learned that light is a form of energy. We know that the sun is the prime source of energy. The sunlight, the heat that we get from the sun, that is known as solar energy. With the help of light, we see different objects around us. We see each other with the help of light. Now children, we know that the light helps in photosynthesis. The plants trap the energy of the sunlight and do the process of photosynthesis. And also we learned that the objects that produce their own light are called luminous objects, such as the sun, stars, the electric bulbs when they are switched on. All these are examples of luminous objects. We learned about non-luminous objects. Those are objects that cannot produce their own light. They are the non-luminous objects. Students, the light is having so many properties. The light travels in straight line, refraction of light, reflection of light. All these are the various properties of light. Many of the properties we will study in this chapter, and other properties we will learn in higher classes. So students, one of the property, that is the rectilinear propagation of light, that we are going to learn in this video. What is the meaning of rectilinear? We studied in the last year science rectilinear motion. When the motion of an object takes place in a straight line without changing the direction, as a ball dropped from a height, its motion can be referred to as rectilinear motion. And just like that, the rectilinear propagation of light means the light travels in straight line. To show the rectilinear propagation of light, there is an activity. We want to take 3 equally sized cardboards, puncture a hole in the middle of them, exactly in the middle of the 3 cardboards. Name the cardboards as A, B and C. Light a candle on a stand. Arrange the cardboards one after the other in a line. From behind the third cardboard C, when we look at the candle through the holes, we can see the candle light. How we see the candle light? That means through these holes the light travels in straight line and reach into our eyes. That's why we can see the light of the candle very clearly. So that is the experiment to prove that the light travels in straight line. Now students, if one of the cardboard is taken, slightly change its position, means lifted slightly, then we can see that we cannot see the candle light. We cannot see the candle light when one of the cardboards change the position slightly. So this experiment proves that the light travels in straight line. Another activity to prove that the light travels in straight line or the rectilinear propagation of light, take a drinking straw, a straight one. Look through this straw at different objects or the light of a bulb. We can see the light or we can see the bulb through the straw because the straw is straight and the light rays comes from the bulb straightly towards our eyes and we can see, but we just bend the straw. We bend the straw, make a bend in the straw and try to look at the bulb. Then we can understand that we cannot see the light of the bulb. The reason is that when the straw was bent, the light rays were stopped. They cannot travel straightly. They were stopped at the bent part, so we cannot see the light. So these are the two experiments, cardboard experiments and the experiment with the straw, that explains the property of the rectilinear propagation of light. Now students, the rectilinear propagation of light has the following effects. Here a pinhole camera makes an image with the rectilinear propagation of light. On the screen of the pinhole camera, we can see an inverted image, inverted and real image we can see on the screen of the pinhole camera due to the rectilinear propagation of light. From the bottom part of the object travels through the hole of the pinhole camera and it travels straightly and forms the upper part of the image, and upper part of the object becomes the lower part of the image. So we get a clear upside down or inverted. Upside down images are called inverted image with a pinhole. If the pinhole is small, the clear image, somewhat clear image is formed. But if the pinhole is larger and if the camera is brought nearer to the object, the image also will be larger in size. Then when we talk to a person who is standing at the opposite other side of the wall, we can talk and hear the sound of the person, but we cannot see the person. We can hear the sounds because the sound can be transmitted through the air and reach into our ears. But we cannot see the person who is standing at the other side of the wall. The light rays cannot travel through the wall. Wall is opaque. That is one reason. Another reason is that the light rays cannot bend and comes near to us to form an image in our eyes. That's why we cannot see the person, but we can hear the sound of the person. That is also due to the rectilinear propagation of light. Then students, the shadows are formed due to the rectilinear propagation of light. Light travels in straight line and form shadows of opaque objects. So this one we can read. The shadows are formed because of light travels in straight lines. When light falls on an object, it gets blocked since it cannot curve and move around the object. So a dark space behind the object, which is called the shadow of the object, is formed. Then we can hear people behind a high boundary wall, but we cannot see them. This is because light cannot bend around corners. And when the rays from an object cross a pinhole, these 3 points we already discussed, we have seen. And the third effect of rectilinear propagation of light is in the pinhole camera, the images are formed because of the rectilinear propagation of light. That means the rays from the top half of the object are below the rays from the bottom half. Their positions remain unchanged because light travels in straight lines. So when they fall on a screen, the image formed is inverted. So students, in this video we learned about the rectilinear propagation of light and its effects. I hope you understood all the things that are discussed in the video. Thank you.